In this video, we'll draw the Lewis structure for IBrCl-. So first off, let's count the valence electrons up before we draw the Lewis structure. Each one of these elements is a halogen. It's in group 17, sometimes called 7a. So we have 7 plus 7 plus 7, and then we have an extra electron. So we need to add that there. That gives us 21 plus 1, 22 total valence electrons for the IBrCl- Lewis structure. So we normally put the least electronegative element in the center of our Lewis structures, and iodine is the least electronegative element. But it's pretty close here to bromine. So since it's written this way, I'm just going to keep it this way, just because the electronegativities aren't that huge. The difference between electronegativities aren't that huge between I and Br. So we have 22 valence electrons. We'll start by putting a pair of electrons between atoms, and that's going to form our chemical bond. Then we'll go around and complete the octet on each atom here on the outside. At this point, we've used 16 total valence electrons. The iodine has an octet, the chlorine has an octet. So let's put 2 more on the central bromine here. Now we've used 20, but we have 22. So everything has an octet, but we have 2 electrons left over. We've only used 20. We could take a pair and put it on the central bromine. Bromine would have more than 8, but that's okay. It can have an expanded octet. If we check the formal charges, we'll see that the iodine and the chlorine, they have a formal charge of 0. The bromine has a formal charge of -1. So the formal charge being -1, that supports the idea of the bromine being in the center. That's because bromine's a little bit more electronegative than iodine, so we would expect that it would have the negative charge here. We should put brackets around this since it's an ion. And then we'll put a negative sign out here. If we wanted to look at the molecular geometry, we could use the AXE notation. A, that's the central bromine. X, that would be the atoms on either side. We have 1, 2. And then E, that would be the number of lone pairs. We have 1, 2, 3 lone pairs. So we'd end up with AX2E3. And that would actually be a linear molecular geometry. The orbitals, 3 orbitals around the equator, they'd be 120 degrees. And then we have the 2 orbitals on the vertical axes, they'd be 90 degrees. So this is the Lewis structure for IBrCl- in the molecular geometry and bond angles. And this is Dr. B. Thanks for watching.